We have last time covered functions and lambda functions, and then the other functions like map, reduce. That is what we saw last time. So what we are going to cover this time around is, and the respective exercises is already available there, right? When you look at exercises inside functions, it will have all of these. So we have map, reduce, and filter function exercises also available in the same exercises workbook. What we are going to see today is exceptions handling, as to what exactly is an exception, and we are going to actually start our discussion on some of the common classes, right? This is going to be a very easy module, common classes and exception handling, and then we will see if we actually can do both of these today. Otherwise, what we will do is we'll do maths today, and we'll do date tomorrow, and then we will start with the classes in Python as well. Classes in Python is going to be when we actually look at how do we implement the object concepts inside Python. This is not something which you may need to actually require to implement for your data science needs, but we are definitely going to look at it so that if there is a code which is written using classes, then you can actually comprehend, right? And you can actually understand as to what is happening there, right? You should not be having no idea about classes in Python, although you may not be required to write your code this way. So let us get started. We will start with exception handling first, and then we will move to the common classes. So we already have a notebook built for this, right? And first thing that you need to actually look at is understand is what exactly is an exception, right? So there are two things, right? There are two things that we need to know, and that is what we are going to look at, right? So let me get started by sharing a white screen, and there we need to actually figure out what is an exception, right? So let me just try and explain this. So there are exception is nothing but a special type of a error, right? So when your program executes, you see when your program executes, you do at times end up getting errors, right? So what can happen? Let's say if you have written this code, right? If you have written this line of code. Wait. So when you have written this line of code, uh, print with a P capital, right? And then you specify something, right? Uh, this is my message. Then what happens? When you run this code, an error has occurred, right? Now, what is this error? It says name print is not defined, right? Now, what is the problem? This function is not a defined function. It is not either a system defined function or nor it is a user defined function. So since the compiler does not know what this statement is, it is giving you an error. Now this is an example of an error. What we need to understand is what is an exception and how it is different from an error, right? So first we need to understand what is an error, and then we will get back get down to understanding what an exception is, right? So this is one error, right? This is an example of an error, right? What we have seen is an error. It says name error. Okay, another example, right? Let's say we define a variable x, right, and assign this a value 10, and then we want to print the value of x. And what has happened here is instead the variable that you've defined is small x, but here we have actually tried to print capital X. Now what is the problem here? Again, a name error, right? What is happening? Second line has a name error. It says name capital X is not defined. So now this program is syntactically correct, right? This program is also syntactically correct. It's just that name of the function is not defined, and that is why we have a name error. The same thing is happening here as well. There is no syntactical error here, right? Variable is equal to value is a syntactically correct statement. Now print is also a defined function. The problem here is that we are printing another variable which is not defined, and that is why we are getting an error which says name x is not defined. So how to resolve this? We can actually define a variable with capital X as name, and when we do that, then my program will have a valid output. So what was happening is all of these were syntactically correct statements, but okay, so now this is printing correctly because we had defined it, right, once. So let me change it to small a and capital A. And now we have the same problem again. Name A is not defined. So I will leave these two lines of code here for you to actually understand that what exactly is an error. Now, this is an error because, this is not defined. This is an error because this is not defined, right? And when is this actually getting uh, when this is actually getting caught, when is this error getting caught? During the execution, right? There is no way this can actually get caught in the compile time, because during the compile time what happens is the program is checked for the syntax, and if the syntax is correct, then the compiler is not going to give you an error. The only problem is when you run this, you do not find a print statement, or a print function, and here you do not find a variable which is defined already, which is capital A. So during the runtime, you're getting an exception, and the this is the difference between a error and an exception, right? So how do you differentiate between an error and an exception? See, there are two types of errors that you can eventually get, and the first one is called an error. The other one is called an exception, and we need to understand the difference between the two. So how do we understand this, right? So we have an error and we have an exception. Both are errors, right? Both are errors. Error is also an error, exception is also an error, right? But then this happens during the compile time, right? Whereas your exception is going to happen during the runtime. By runtime, what do you mean by runtime? When the program runs. By compile time error, what do you mean? When the program compiles, right? So this error, this category of error, you're going to get when your program is compiled, right? And this category of error you will get when your program executes. Now, what will happen in case of an exception is your program will compile successfully, right? So this is your first. The second statement to make here is that program compiles successfully, right? Here it gives compile time error. Again, we already said this, right? So compilation gives error, right? Number two. Now, what happens in case of an exception is it gives an error during runtime. Error during runtime, and this is since you cannot run it. You cannot run it. ये run ही नहीं कर सकते because you are not able to compile it, right? First, you need to compile the program and then you can run it, right? Since you are getting a compilation error, you cannot actually go ahead. You cannot do this. This is not possible. In this case, since your program does not give any compilation error, the program compiles successfully, right? You can actually run this, but then during the runtime, it will give you an error. So this is the basic difference between an error and an exception. I'll give you one example, right? So let's say you have tried to boot your system, right? You've tried to boot your system, and then your system boots, right? Your Windows boots and your system is up and running. So that is where your program, the Windows program, has started to function, right? And take charge of all your hardware resources, and that is how your system boots. Now, what happens suddenly when one of your programs is trying to excessively use the CPU or excessively use the RAM, right, the primary memory? Your system starts to become slow, and eventually, what do you get? You get a blue screen of death, right? You get a blue screen of death. You may have, I mean, we may have all seen this, right? Where Windows gives you a blue screen of death, right? What happens in that case? So let either your all your memory gets exhausted, right? So memory exhausted, that is one of the common reasons. Or the other thing is some exception occurs. Some exception occurs where? In your Windows application, the operating system. So when this happens, then what happens is you get a blue screen of death, which means something has happened during the execution of the program, right? Something has happened during the execution, the runtime of the program. And what is the program which is running? Windows is the program which is running, right? So a blue screen of death that you may have already seen, right, multiple times with Windows is an example of an exception. This is an exception. If there is an error, then the program will not load itself. But if the program is loading and it is actually crashing in any manner, then that is an exception, right? So I think with this, you will have a fair bit of idea as to what is an error and what is an exception. So with that, what we will do is we will get back to our example that we were trying to do here, right? And what we will do here is we will actually try to see as to how do we handle exceptions. Now, why do we need to handle exceptions, right? We need to handle exceptions because we do not want our program to terminate abruptly, right? What happens in case of a blue screen of death? A blue screen comes with details of the error, and then the only option that you have is to restart your machine and see if Windows works or loads the next time or not, right? Now, why is that the case? Because during the execution of the program, some error has occurred from where it cannot recover, right? So when an exception occurs, right, when an exception occurs, then what are the possibilities that you have? You need to actually rerun the program, right? That is the only option that you have. You need to rerun the program. There is no other option for you to make, right? So you need to rerun the program. In case the other, what is the other option, right? So this is one. The other option is you write your program in a manner that you handle the exception, right? So either rerun the program or change program code to handle exceptions. So I'll just give you an example as to what do we mean by handling exception. So handle exception, right? So handling exception, the one example that I can give you is, let's say we were talking about memory exhausted, right? So your Windows, you have 8 GB of RAM, right? And Windows, if Windows allows any program to actually use all of it, right, 8 GB of RAM, then what will happen if another program needs access to your primary memory? It will not be able to allocate, right? And in that case, the new program will never be able to start. It will keep crashing. But if you write your program code in a manner that if there is an exception and you handle that exception, then at least your program will not crash, right? It will not abruptly terminate. And that is the role of exception handling, so that you can get a valid error instead of uh, crashing the application or terminating the application abruptly. And this is what we are going to see here. So what we are going to see here is that when we run the program which has some code which is unnamed, or name print is not defined, or unnamed variable which is being used, then how can we actually control this program so that we do not get a error like this, right? And we can actually generate a error of our own. That is what we are trying to do here. So uh, with that, let me get into the code part as to how this is possible and how do we actually do this. So to be able to do exception handling, we use the try and except block primarily, and this is what Python lets you do if you want to do a exception handling. So anything that you any line of code that you think is going to generate an exception in the runtime, you write it after try. You write it up in the try block. So this is the try block. The block of code which is right after try is called the try block. And if you think that your program code is going to give you an exception, then if you want to handle that exception, then you need to write that same program inside the try block. So what we are trying to do here is we will just do the same thing here, right? We'll copy this statement here, and now we are going to just put it here, right? So see what is happening in this case. So this is the same error, right? This is the same program code, but now we have written that inside the except try block, right? And let's see what is happening. Now the same program is not giving me this error. Name is not defined. It is giving me this message. An error occurred, right? Let me change this, and let me change and put some relevant message, right? Is not defined. See what is happening? So what is happening here, right? If you look at this more closely, then I have these two lines of code, and primarily this line is invalid because when the program tries to print the value of capital A, it does not find any variable which is defined before this statement, which has a name as capital A. So this line of code will ideally, if not written inside the try block, will give you a runtime error. And this is an example of a runtime error, which is saying name error. But this time around, since it was inside the try block, it did not give you this error. Why? Because any program, any line of code that is written inside the try block, why do we do this? Because we want to do exception handling. We do not want the program to terminate abruptly. And what is happening here is the moment any line of code written inside the try block gets into a runtime exception, the program, instead of terminating, moves the control back to the except block, right? I'll just draw something to show that to you as to how this is working here. So if you write a program code inside a try and except block, right, then what happens is, so here we have the try block, and then we defined a is equal to 10, and then we are printing, this is small print p by the way, printing capital A, and then we have except block, right? And here we are printing some error message. So what is going to happen is the program will start executing from this line. So this has no error, so this will execute successfully. Now this program will now move to the next statement, which says print A, and here we have a exception. So what will happen in this case, the moment this program encounters an exception, and this line, which is actually causing the exception, if this line is inside a try block, right, then this program will not terminate. This program will not terminate abruptly, right? What will happen in this case, the moment it encounters an exception, the program control is going to move inside the except block, and whatever is written inside the except block, that is going to get executed. So the moment you have an exception, the control moves to except block. If there is no exception, the program will not go to the except block, and that is how it works, and we will see that. So since this line of code resulted into an exception, the program control moved inside except block, and what will happen in this case is you will get a message whatever is written here. So it will print a message, error message. All right, so this is what is getting printed, and this is how actually the control is moving from a try to except block. So I'll just show that to you here. What is happening here is this line of code is actually resulting into exception, and that is when the control is moving into this except block. Let's say we define a. Let's say we define a, right? We define a is equal to 10, and then we print the value of a. Then what will happen? See, since there is no exception now inside try block, my control is not moving to except block. And this is the beauty of using the try and except block. The program code is only going to move to the control of the program flow is only going to move to the except block when there is an exception. Otherwise, the except block is not going to handle. So think of this as a firefighting. When there is an exception during the runtime, then except block takes charge and the control moves to except block. If there is no problem, if there is no exception during the runtime, then the program control does not move here. As simple as that, right? So what I will now do is I will actually change it back to another variable so that your program code moves to except block and you can have an example which makes more sense for exception handling. Unless and until there is an exception which happens here, except block is not going to execute. So with this, guys, do let me know if you have any questions. I think we have covered a new concept, and if you have any questions, do let me know before I move forward.
No questions.
Okay, all right, so straightforward. Okay, so let's move on and see some of the other variants of this, right? So there is also with the try and except block, there is also a else block which is available, right? And think of this as if the exception happens, then do this, else do this. So in this case, the program code is going to, the control of the program flow is going to either, if there is an exception, then it will execute the except statements. Otherwise, it will always print the else statements, right? So here what we are trying to do, we are trying to do print hello. And if there is any exception here, then it will print something went wrong. And if there is no exception, then it will print nothing went wrong, right? So let's see what happens here. It is first printing hello, which means this line is getting executed successfully, which means there is no error. And since if there is no error, uh, the program code is not going to move inside this statement, it is going to move here, right? So why would you need else statement here is when you actually want to handle both the situations, right? If the error occurs, then do this. If the error does not occur, then do this. If that is the case, then you can actually use the else statement as well, and that is what we are trying to see here. So hello is what printed here, and then nothing went wrong is printed here. But let's say if we put in this statement here, right, then see what happens.
Means why printing red color or
Sorry,
why printing in red color?
uh, your voice is not clear, Gajendra. Can you come closer to the mic?
I'm saying that why printing red color?
Why printing what?
Why print keyword is in red color?
Sorry, your voice is not clear to me. I don't know if this is a problem at my end.
Hello, can I
Uh,
hear you?
uh, y- it is very low to me.
Hello,
Hello, yeah.
is it better now?
Yeah, it is somewhat better. Tell me.
So I'm saying why print keyword is in red color?
Oh, yeah, this one because of the indent. Because of the indent, it is not at the proper indent. This is what you're asking for, right?
Yeah, yeah, yeah.
It was not indented correctly, and that is the problem because of which print was in red color. Sorry, I could not actually hear that properly. So when I indent it correctly, it moves to the C. When I indent it correctly, after four spaces, it becomes green. Okay, so what is happening here? Right now, we are trying to see. Earlier, there was no exception because there was just one print statement, and that is why it was moving to else and printing nothing went wrong. But now, when we have put in some error message here, right, or exception statement, then it is moving to something went wrong. So you to be able to figure out as to why and when except and else blocks will execute, you can actually figure it out by changing the program code yourself. And now you know how to actually generate an exception, right? Anything which is not defined that you're trying to call will generate an exception. That is the easiest example of it. So I'll leave this program code like this only, but you can just, put a comment here and then make it move to the else statement as well, right? So I'll leave this commented for now so that you can actually try both of these. So moving on, right? What is happening here? Yeah, so what is happening here? Try print x. We have a finally statement, right? Uh, what is finally and how is it different from else? So what happens in case of else is either the program will move to this part of the code if there is an exception, or it will move to else if you do not have the exception. But finally is one block where the program code is going to go always, right? Either whether the exception occurs or not. It will always go to finally. And this is the difference between else and uh, finally. So in else, either the program control was either going to accept or else, but here either even if it goes to accept block or not, finally is always going to get executed. I'll give you an example as well, right, of where to use it. So let's say what is happening here, right? We are printing the value of x, and since there is no error here, what is happening? Uh, s- this exception is not getting generated. But look at finally, it is actually printing this value. Now let's do one thing. Our favorite line of code, right? Let's copy it here and see what is happening. Now we have an exception, and the control is moving to the except block, right? Which says something went wrong. But it is also moving to finally block. And this is what I was trying to tell you. Whether the exception happens or not does not really matter. This finally block is always going to get executed. So it is printing the try except is finished, right? So one example, right? One example of when to use finally, right? And that is what we need to see, right? So a lot many times what you need to do is, and this is primarily during file handling or database handling, right? So when you need to do database handling, right, what are the steps in database handling? You first create a new connection, right? This is an example of, or these are the steps which are involved in database handling. So in database handling, you first create a connection to the database, right? I'm just going to write short db, create a connection to database. Then what do? You open that connection, right? Which means that you make that connection, right? You make that connection. So you connect to the database. Simply, you can say connect to the database, right? You do that. And then what do? You execute your statement, execute your SQL statement. And this is all programmatically, right? And we have a module where we will be actually doing all of this. So we will cover this as well. It is going to be covered in database handling, right? So we are going to do all of this here. And this is primarily going to be our last module. So we will see all of this there. But then primarily what you need to understand here is that where do we use the finally block. So execute your SQL statement, and at the end of it, right, what we need to do is uh, close the connection, right? When you open a connection, you always need to close the connection, right? Now, this is going to be the example, the program flow, right? So you create a connection, you open the connection, you execute your SQL statement, and then you close the connection to the database. If you do not do that, then what is the problem that you have is, and then this is kind of a standard, right? Whenever you open a connection, you always close it at the end of the program once we are done with this, right? If you do not do that, then opening another connection may become a problem for you because your previous connection or previous session is still active with the same database. Now, let's say these are the 4 lines of code, right? Actually, these are going to be more than 4 lines of code, but let's say these are the 4 lines of code that you have written. And let's say this executes successfully. This one also executes successfully. But what can happen here is when you execute your SQL statement, your query is actually going to run at SQL Server or Oracle, and then this is going to give you output back to Python, right? Now, your SQL Server may be down, it may be busy, the request may time out, your internet may not be working. There are so many things which can go wrong at this step. But the thing is that even if there is a problem at this step, you should always close the connection. That is a mandatory step. This should always run. Even if your program code executes and fails at this step, you should always close your connection. Now, how can we do that? To do that, what we will do is, this is my try block. I'm just writing the line numbers, right? So I will create my connection here. I will open my connection inside the try block. I will also write my third statement, which is execute your SQL statement here. And inside the except block, I will write whatever I need to do to handle if there is any exception. But this needs to always happen, right? So I cannot write this statement inside my except block, but because except will only execute when there is an error. But my requirement is that whether there is an error or not, I should always close the connection. So now you must be getting an idea as to why this is important for us to write this fourth statement inside finally. Because finally is always going to execute. This will always execute. So my closing the connection part is going to always be part of my finally statement. Do let me know, guys, if you have any question here. But this is important for you to understand. We are going to use this concept later on in database handling. Did you understand the difference between else and finally?
Yes, Manish.
Sure. So, okay. All right. So finally is primarily used to close the connection. Now, this is also true for file handling, right? File handling, right? There also we follow the almost the same steps, right? So you open a file, then you read data from file. It could be a CSV, and then you close the file. Close the file. Now the thing there is also the same, right? When you open, this needs to always happen. And what can go wrong here is something at this step, right? So if your read operation times out or fails or whatever happen gives you an error, since you have opened a connection, you need to close the connection to the file. If you do not do that, then your file might get corrupt. And that is where your finally block is going to help you. So finally is very important, as I showed you, because most of my code which is mandatorily required to be executed is irrespective of an exception happening or not needs to go inside finally block, right? So this is a very good example of finally you need to actually close all your connections using the finally block. That is where it is required. Now we're going to see a few common errors, right? Two of them where actually you can use this statement. So can you tell me what is the problem when I write print A by B? What is the problem? Let's say I do not have this.
By zero error.
Sorry.
Division by zero error.
Right. So the problem is that there is no syntactical error here, right? A is equal to 5 is a valid statement. B is equal to 0 is also a valid statement. And A by B, print A by B is also a valid statement. But when you run this program, the compiler is not going to give you an error, but during the execution, it is going to give me an error, right? You cannot define, uh, you cannot divide any number by a zero, right? That is going to give you divide by zero error, right? But we can actually handle this, right? We can handle this using this statement, right? So that is why I had commented this. Since this is going to give me an error, trying to go, just going to get inside a try statement, like write the same statement inside try. And what will now happen is there are these specific exceptions that you can catch, right? And I will let you know if it could be, a specific ones, or you can either write a generic one, right? So zero division error is the name of the exception, right? See, what is it that was, this is a statement, right, which was getting printed. It is saying zero division error, right? Zero division error. So this is the name of an exception actually, runtime exception. And that is what we are trying to write here, except zero division error, print error occurred, right? So what will happen in this case? When zero division error occurs, right, then this is except statement is going to get executed, right? And it is going to do whatever you have entered here, right? Uh, and let me make it divide by zero is not supported or something like that. You can specify your message here, right? So now you do not have an exception. Now, if you do not know the name of the exception, that is totally fine. You can even just write except, and that is also going to give you the same output. But it is advisable if you know the exception name and if you want to catch specific exceptions, after the exception keyword, you can actually specify this, right? So let's say there are multiple lines, right? There are multiple lines in your code, right? So this is one example that we need to actually look at. And with that, we'll be done with exceptions. So let's say you have multiple lines of code inside try. This is my try block. This is my line 1. This is my line 2. And this is my line 3 of code. Now, hypothetically, what is possible is this may give me error which I am calling error 1. This may give me an error which I am calling error 2, and this may give me an error which I am calling error 3 hypothetically. Now what you can do is, if you just specify except, then whether error 1 happens or error 2 happens or error 3 happens, every time the program is going to get inside this except block, because I've not specified any specific error that I'm catching, right? But let's say if you want to do something different, right? So the steps for error 1 is going to be step 1. Er, Step for error 2 is going to be step 2. And the step for error 3 is going to be step 3. If that is the case, which means that you want to do something different in case of error 1, you want to do something different in error 2, and you want to handle step 3 differently, error 3 differently, then you need to actually specify multiple except blocks. And here we can write error 1, and then you can specify this is my step 1, except error 2, I can do step 2, except error 3, and then you can specify step 3. So what is happening in this case? My error 1 is going to get handled separately. My error 2, if it happens, then this is going to get handled separately. And if my error 3 happens, then this is going to get handled separately. And if any other error happens, in that case, the program control is going to get to the generic one. So I hope this kind of clarifies what is the difference between a generic error where you do not have a error name specified, and what is the difference between a generic error and a specific error. So specific error, if you specify, then the program code is only going to move here when this error happens, right? And this is what is happening. I'll just give you an example here to show you as to what is happening here by adding another except block. See what is happening? I have two except blocks, right? One is to catch specifically this error, right? Divide by zero, and another one to uh, capture any specific error. Sorry, any generic error, right? Now this is not getting executed because every time it is throwing a zero division error, right? But let's say before this statement, I write print m, then see what is happening. Now this exception has occurred, and in this case it is actually not a divide by zero division error, right? This is a name error. This is a name error, right? We have not defined m, so this is actually going to except block, right? So you can actually write multiple statements as well. You can write multiple statements as well. What I'm doing is I change the order. So now this is resulting into an exception, and now it is moving to divide by zero is not supported. We can also specify the name error here, right? That is also fine. Now if I move this back to here, then this is going to actually print this statement. I should just change this name as well. This is name error. And if you really want to add any generic exception block, then you can add in a generic error. But then this is going to catch zero division error, name error accordingly. So what I will do is, since I wanted to actually demonstrate to you guys the division by zero error, I'm actually putting this on top, right? So you can actually do multiple ones, multiple except blocks as well. And this is totally fine. How do you get the name of these? By actually looking at the error message itself, right? It specifically tells you the error name, right? So name error, division by error, all of this will get printed in red when the exception occurs. So how do you know what exceptions you need to handle? Now, this could be part of your requirement that you get. And if not, then what happens is this can be done reactively as well, right? So when your program crashes, then you look at the crash log and find out what are the exceptions which has happened. And then you can actually modify the program code to include those exception statements to handle the program. The good thing is that when you do exception handling, the benefit that you're getting is your program is not crashing intermittently. You are actually handling that during the runtime itself. So let's look at another example of uh, a very common exception handling case, right? Where you can actually implement this. So one thing which actually happens is a lot many times when you do not know the size of any list, right? And if you want to, let's say, print all the elements of the list, and somehow you make a mistake in reading the number of elements, right? Then what will happen here is we'll just see, right? So we have 1 2 3 4 5 6 7 8 9 10 10 elements in the list, right? L is a list, and we have 10 elements, 1 to 10. Now what we are trying to do for I in range 0 to 15, right? And we are trying to print the Li, which is we are trying to print the elements of the list, right? Now you always know that the elements start with 0, and the 10th element will have an index of 9. So this has an index of 0 and this has an index of 9. So what will happen in this case is, see, Okay, we need to first execute this. So let me just put both of these lines in the single block, and let me just delete this. So what is happening? It is printing till 10, right? It is printing till 10, and then it is giving me a index error. Now the same statement is executing 10 times, and then on the 11th time it is giving this error, list index is out of range. Why is the case? Because this loop, if you look at it, it is running from 0 to 14. And what is the index available for L? This is only available from 0 till 9, right? So uh, the moment it tries to fetch L10, this is when it is actually getting that error, right? And why? Because it says list index is out of range, right? So what is the range of the list index? The range of the list index is 0 to 9, right? And we are trying to do 0 to 14. So that is the reason it is actually giving me this error. Now, how to handle this? Simple. I told you whatever statement you feel or believe is going to give you an exception during the runtime, you put that in the try and except block. And that is what we are going to do next. So we left the uh, we left the for loop outside. This is the statement which is likely to give me an error, right? Or exception. Then I put this inside try block, and then inside the for loop I also have the except block. A try block has to have a except block, at least one except block. And what is the error we are trying to capture here or catch here? See, what is the error that we got? We are going to catch the same error, right? Index error. So which means whenever an index error occurs, the program is going to move to this block, right? And print index out of bounds. Now, how many times it is printing this statement? 5 times. For values, index values 11, sorry, 10, 11, 12, 13, and 14, right? It is actually printing the value of li 10 times because the first 10 times there is no problem. The index is within the range. For the next 5 times, the index is out of the range. So it is printing index out of bounds 5 times. So do let me know if you guys have any questions. With this, we are kind of done with the try and except block. Primarily, this is a very fairly simple concept we need to use for exception handling. Any questions, guys?
So,
Okay, all right. So I will upload this workbook, guys, on the dashboard so that you can actually refer to this and run this program, set of program codes to actually uh, see it yourself, right? Now, moving on, what we will do is we are going to look at some of the common functions. So let's start with math for today, and then we can probably see if we can start date or we can do that tomorrow. So common classes, right? Math. So we have a class named math, right? Now what it does is it gives you a very few,
be in the price.
yeah, so what it does is it gives you, different functions, right? So that you can do some of the mathematical operations very quickly. So I asked you guys earlier as to how can you do a square root or how can you do a factorial if that is a requirement, right? One way is you can calculate it numerically if you know the formulas, and the other thing is that you can actually make use of the math function. So as the name of the class suggests, this is going to include all the functions, the common functions that you will need to do any mathematical operation, right? So let's see what all we have available here, and this is going to be much easier, right? So what you need to do is you need to first import math class, right? So that is what we have done, imported math class. The name is math itself. Since the name of the class is very small, we are not using any alias. Otherwise, what you can do is you can provide a alias name as well. Import math as M or MA, M1, whatever you want to specify. But since the name is very small and readable, and self-explanatory. We usually do not use any alias for this class. So what are we trying to do? We are trying to actually define a variable a is equal to 2.3, and we are actually going to see the how does these two functions work, ceiling and floor, right? So ceiling will actually help you in rounding down the value, and floor is going to, sorry, rounding up the value, and then this is going to round down the value, right? So let's look at it. This is going to be very self-explanatory as to what it does. What are we trying to do? The seal of the value, right? The seal of the value 2.3 is, and what are we trying to do? We are calling this function called ceil, ceil, and then we are passing the value of a, right? So what it will do is, since the value is 2.3, if you round down the value, if you round up the value, so ceiling is what? Ceiling is on top of our head, right? So think of it this way: floor is below us, and ceiling is above us. So ceiling is going to round up the number. So 2.3, if you round up this number, this is going to become 3, and floor is below us. So if you round down, floor is going to get used for rounding down, right? So if you use a rounding down function, then this is going to actually round down the function to the nearest decimal, right? So 2.3, if rounded up, becomes 3.0, and floor, if you do the floor of 2.3, then this is going to actually round down to 2, and you can use it for any number, right? So you can use it for 7.45, and let's see what happens. So 7.45, ceiling is going to be 8, and floor is going to be 7. So you can use it for any of these. So if you really need to round a number, if you need to truncate the decimal part, but what is happening here is, you're not just truncating the decimal part, right? If you truncate the decimal part, then 7.45 or whatever number will always have the number prior to the decimal, right? It will always be 7. It will never become a 8. If you need to round up, then you need to use ceiling. If you need to round down, you need to use floor. So very common function, guys, and very simple to use. You just need to write math.floor, math.ceiling, and pass the value. Now look at a few others, right? F ABS function and factorial function. So I think in one of the exercises I had given for a practice exercise where you needed to take a number from the user and then calculate the factorial, right? Which is, factorial 5 is going to be 1 into 2 into 3 into 4 into 5, and factorial 7 is going to be 1 into 2 into 3 into 4 into 5 into 6 into 7, right? So multiply all the numbers starting from 1 till that number. That is what the factorial is going to give you. Now there are functions defined inside math class that you can actually call to do this without you requiring to actually calculate it manually, right? And why all of these functions are defined? So that you can actually do these quickly. That is one, and your focus is mostly on the, if you do this, if you call these functions, then your focus will remain on the data analysis and not actually will move to writing the code, or devising the logic for factorial and all, right? So let's see how you can actually use this, right? So first, let's look at the factorial, right? So I have a number defined as b is equal to 5, and I'm doing math.factorial b. So what this is going to give me is going to give me 120, right? So 1 into 2 into 3 into 4 into 5, when you do the maths, you get 120. Otherwise, what was the other option? We may have to run a for loop, right, to do this mathematical operation. 1 into 2 into 3 into 4 into 5, and that will also give me 120. But here we can actually do it really quickly using the function. Okay, what is if ABS, right? So if ABS actually gives you the absolute value, right? And what is an absolute value? Absolute value is the same number without the sign, right? So what is the absolute value, right? So, and this is the notation that you use for absolute, right? Absolute A. This is the mathematical notation that you use. So let's say the value of A is equal to 5, then absolute A is equal to 5. If the value of A is equal to minus 10, then absolute A is equal to 10. So what does happen? If it is positive, if A is positive, absolute value is also positive. If the value is negative, then it truncates the, or drops the negative sign. It makes it positive. So whatever the number is, it'll always, the absolute value is always going to be the positive number of it, right? So in case of a positive number, nothing changes. In case of the negative number, the absolute formula gives you the positive number of the same number. Or you can say that, you can, just for understanding sake, you can say that you multiply this number into -1 and you get this. So it simply means, absolute simply means that you drop the negative sign. If the number has a sign of negative, you drop it. If it has positive sign, then you don't do anything, right? So that is what it is trying to do. In case of a -10, it is actually printing this as 10. Absolute value of -10 is 10. But let's say if my number is positive, then what happens? We'll need to change this message as well. So if the number is positive, then absolute value of 10 is also 10, right? So this is only going to make a difference when the number is negative. So that is also a requirement. At times you need to actually take the absolute value. You can just use FABS, and factorial you can use factorial. The names are very self-explanatory, and what you can do is when you write type dot and then press shift plus tab, then you actually okay, so it is not actually giving you all of these function names here. Yeah, so math dot and just tab, right? So when you do tab, so what I'm doing is, let me just do this again, math dot and tab. So when I do tab, it is actually giving me all the functions which are available. So these many functions are available, right? We have pi, we have POW, power, we have SQRT, square root, we have radians, remainder, we have NaN, we are going to look at it. We have log 2, we have log 10, we have log, then we have greatest common divisor, GCD, then we have floor, we have already seen, we have factorial, we have FABS that we have seen. So, right, so all of these are functions that we can actually use, right? Every function is going to have a different need, and then how can we know as to what this function does? Get inside, get your cursor inside the small brackets and press shift and tab, and then this is going to give you the definition of it, right? As to what does it do. So returns the arc cosine of x, right? So cosine value. This is going to give you the arc cosine value of whatever value you specify. So we're not going to get into details of it, but then what you can do is you can always do math dot tab to look at what all functions you have available. You do not need to know all of this. As and when required, you can just search for it, right? So FABS and factorial. Now let's look at a few other ones, right? So what does copy sign and GCD mean, right? So GCD is again something that we may have studied in our fifth or class sixth, right? Greatest common divisor. So if you have two numbers, then what is that number? What is the biggest number that divides both of these numbers, right? So 5 and 15. When you look at it, actually 5 is the biggest divisor for 5 and 15 both. And when you do math.gcd, then this is what it is actually going to give you. Let's say we change these numbers to, let's say we change these numbers to mm, 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 5 and uh, wait, 8 and 12, right? So what do you think you're going to get? 8 and 12. What is the greatest number which divides both of these numbers,
Or
right? So in this case, this is going to be, see, 8 and the GCD of 8 and 12 is 4, right? So this may not necessarily be either of the numbers. It can be any other number, right? So GCD gives you the greatest common divisor. Copy sign is actually very simple, right? So what it does is it copies the sign of one number and applies it on the other number. So what is going to happen is it copies the sign of whatever number you specify in the second parameter and it applies it on the first number itself. So if the second number is negative, the first number will also become negative. If the second number is positive, then the first number will also become positive. And that is what it is doing, right? So 5.5 and minus 10, it is going to print me it is going to apply the sign of the second number, which is negative, to the first number, which is positive, and it is going to actually print me minus 5.5. So it does not have a lot of applications, but then this is also one of the very common functions. So moving on, right? If you look at it, we have exp exponent, and then we have log, right? So what is exponent, right? So exp exponent has a value of um, so when you look at it, let me just correct this. Yeah. So we can print math.e, right? And this is going to print me the value of small e. And the value of small e is actually 2.718, right? You can look at it, you can Google it and then find out. You must have already studied in your algebra, class 6 to 8, somewhere in that range, right? So if you need to actually calculate the value of e, then the value of e is, if you recall this, 1 by factorial 1 divided by 1 by factorial 2 plus 1 by factorial 3 plus 1 by factorial 4 plus so on 1 by factorial n. If you do this, then what you get is equal to small e in mathematics, right? So that is what the small e value is going to be. And if you really need to do this, then you don't need to do this calculation on your own, right? You can just call the e uh, you can just call the constant, right, with math.e, and that is going to give you this number. Now, in mathematics, what you can do, you're required to do is you are required to actually calculate some of these statements, like e to the power 4 or e to the power 2 or e to the power minus x or something like this, right? If you need to do this, then you can actually use the exp function, exponent function, and then whatever power you need to specify, you can specify that inside the bracket. So what is happening here? This is going to give you e to the power 4 is going to give you this, which means this is going to give you the value of 2.7182 to the power 4. And this is what you can do by just writing math.exp4, right? So all of this is very simple in Python. You can just call these functions to do this. Now, there's a log function, right? Now, how can you use this, right? First, you need to specify the base, right? Uh, no, the first thing that you need to specify is the log itself. What is that number for which you need to find the log? And then you need to specify the base. So, what is happening here? How do you know that? You can always do a shift tab inside the small brackets to look at the definition, right? So look at the definition. It takes two variables, right? X, and then the other one is a uh, optional. If you do not specify this, then this is the base, right? And if you do not specify this, then it is by default taking the value of e, right? So the default log value is going to be the base of e, small e. So it returns the logarithm of x to the given base, right? This is what the function does. So this is actually returning the log of 2 and the base is going to be 3, right? You can specify anything. And this is how you can actually quickly find out the log of any number. So Finding out the log of any number is very easy in Python. You can just call the math.log function and specify the values accordingly. Now, what do we have next, right? A few variants of log, right? So you must have already known, right, that a log can have any base, right? A log can have a base of 2 or a base of 10 or base of x, right? So you can have log 2 of 5, uh, log base 5 of 20 to 50, log base 10, right, of 10. You can also have log base e of 5. So all of these are different bases, right? And you can actually calculate the log of any value, uh, taking any value as a base as well, right? And that is possible in Python as well. There are different functions defined for this. You cannot just do this for any other value, but then you can definitely do it for log 2 and log 10, which are the most common ones. But let's say if you want to do a log base 7, right? In that case, what we have already seen is we can specify a different base in the second parameter, and then we can use the log function. So if you want to do a log of 2 base 7, you can do that here. Yeah. So here the base is going to be 7. We should change this statement as well. Otherwise, these two lines are going to be different. Yeah. So this is how you can actually play with the bases, right? If you have to find out base 2, then use log 2. If you have to find out with the base 10, then use log 10. If you have to do your any other custom base, then you can use that with the log function and specify that in the second parameter. And that is how you can actually uh, take out log of any base, right? So I think that is very self-explanatory. A few important and interesting functions, right? So these are going to be again very quick, right? So first let's look at the square root, right? So square root is again sqrt. You just specify what is the number for which you want to specify the square root, and you want to calculate the square root, and then this is going to be very easy, right? The value of square root of 25 is 5, right? You can do 36 is going to give you 6, and let's say you specify a numerical value or any value which does not have a uh, a whole number as a square root, then it'll give you a square root of whatever number you specify. So this is square root. The other one is power, right? So power is uh, used this way, right? So if you use power x comma y, then actually this is going to get calculated as x to the power y. So if you're using power 2 3, right, then this is going to get calculated as 2 to the power 3. If you're using power 3 comma 5, then this is going to be executed as 3 to the power 5, right? So this is what you can actually use to calculate power, right? So 3 to the power 2 is going to be 9, but if you do 3 to the power 5, then this is going to be 3 into 3 into 3 into 3 into 3, which is going to give you 243. And this function is actually a little more interesting POW. Let's look at it. So what is happening here? We have specified 9 to the power zero point 0.5. What does it mean? 9 to the power zero point 0.5? It is giving me 3. Can you guys figure out what is happening here?
Yeah, it's 1 by 2 and 2.
So what is happening here is square root, right? Square root is represented like this, right? This is how it is represented. So the way it is represented is 25 to the power 1 by 2 is equal to 25 to the power 0.5. So square root is also represented like this, right? Sorry, I think I it got a little tilted, but then the notation for square root is, I'll take another example. The notation of square root is, this is how you write square root, 36. So it is also written as 36 to the power 1 by 2, and this is also written as 1 by 2 is zero point 0.5, right? So square root is nothing but you raise 0.5 as the power, and this is going to give you 6. So what is happening? This is my x and this is my y. So to calculate the square root, we can also use the power function. But then you need to specify, what do you need to specify? You need to specify zero point 0.5 as the power. So actually, let me do one thing, right? Let me put in 56 here and see the value here. Here we are trying to calculate square root of 56 using sqrt function. And here what we have done is we have raised zero point 0.5 as the power to 56. See, the output is exactly the same in both of these. What does it mean? It means that we can actually use POW, power function, to calculate square root as well. True? Understood?
Yeah.
Yeah. So you must be wondering as to how do we calculate the cube root then, right? Is there a function for cube root? The answer is no. There is no function for cube root, and then we can actually figure out ourselves as to how can we calculate the cube root, right? So let's do this, right? Cube root or fourth root. So what is cube root? Cube root is, you specify this as x, right? Third power of x, right? Which means x to the power 1 by 3, which means x to the power 0.3333, right? And so on. So if you raise any number to the power 0.33, it should give you cube root. Agree or not? Same way, if you need to calculate the fourth root, right? Then what is this going to be? This is going to be x to the power
Like
1.4, x to the power 0.25, and this is going to give you fourth
so,
root, right? So let's see if this is working or not, right? So if you want to calculate any root, then you actually need to use power. And if you want to use square root, then you can actually use square root as well. SQRT, sorry, SQRT. You can also use power function to calculate SQRT. That is also possible. So the choice is totally yours. If you want to use POW for everything, you can do that. If you want to actually use sqrt for square root, that is also possible. So let me actually take one example at a time, right? So uh, 8, and let me specify 1 by 3. So cube root of 8, right? This is what it means. See, we are getting 2. So I will prefer specifying 1 by 3 so that the computer calculates it at 0.3333 till infinity rather than specifying 0.33, right? So I will specify this as 1 by 3. Let's also look at the fourth root, right? So for fourth root, we need to specify the power as 1 by 4 or 0.25. And let's look at a number 16. Now again, fourth root of 16 is going to be um, 2 again. Of course, there is no compulsion. We can take another number as well just to print this. Yeah. So this is going to give you square root. This is going to give you cube root, and this is going to give you fourth root, right? So these are, I mean, POW, the name itself is power, and this function itself is very powerful. You can do a lot of these really quickly using POW. So I think this is very self-explanatory, guys. Let's move on and see a few other mathematical functions. So the next one is pi, right? And if you see, we are not using this as a function, which means it is a constant. And the other constant that we have already seen is e, right? Math dot e. So math.e also does not have a opening and closing brackets after this, which means it is a constant. So e is a constant and another constant is pi. So it will give you the value of pi, right? So let me first print the value of pi, right? And we already know what a value of pi is, right? A value of pi is 3.14, so you do not really need to calculate this. You can just use this constant by writing math.pi. And what are the other functions? We can actually call, calculate the sine and then the cos of any degree, right? So I'm not taking this as an example. I will probably simplify this and specify 30 here. Uh, 45, right? So these are the values of sine and cos for uh, 30 and 45 values. And this is something that you can actually specify. So finding out the value of sine and cos and tan is also very easy. You can just use the sine and cos function accordingly. The same way you can use the tan function as well, and then this is hypertangent, hypotenuse, right? You can actually call these. The only difference is here you need to specify two functions, two parameters, because hypotenuse takes two parameters, and this is going to be exactly the same as sine and cos as well. So nothing much to explain in here. It's just that you can run them and then see it yourself. Uh, I already told you, and I think I covered this already. There are two constants, right? This is not a function. Pi is not a function. E is not a function. These are constant, right? And this is what the message says as well. The value of the constant pi is 3.14. The value of the constant e is 2.71. So we don't need to calculate them. We can just call them using these constant values. Math.e, math.pi, right? So I'm not doing much here. The last bit which we need to check is at times what happens is your variable value, the numerical variable value may not be a number itself, right? And in computer terms, anything which is not a number is called nan, which means not a number, not a number, nan, nan. And how do we actually check whether a number is a number or it is not a number, right? For that we use the isNan function. IsNan would check if the number is not a number or if it is a number, right? So how do you specify a nan value in math, right? You specify a nan value inside math using math.nan. And how do you specify a value which is not a which is a number? You specify a valid number. So this is a valid number. This is a number. And how do you specify a number which is not a number? You can specify math.nan, right? So let's check. How do you check whether the number is a number or it is a nan value? You can actually use this function, right? So what is happening here? We are checking whether a is nan or not, right? So a is nan because we have specified the value math.nan. So actually in this case, this condition is getting true and we are printing this line, the number is nan. And in the second case, my number is a valid number. So the same statement here, math.isNan, is resulting into a false, and that is why it is actually printing me the number is not nan. So when I run this, first, this one is resulting into true because this is math.nan, and this one is resulting into false because my second variable b is a number actually. So is nan is actually resulting into false. So this is also a very important concept. At times what happens is when you need to process any data and the underlying file that you get to process the data, it may not have all the numbers in the correct format. It may have numbers in an invalid format. It could be alphanumeric, it could be string, it could be uh, it could be date, and you're expecting this to be a number. It could be a Boolean value, and you're expecting this to be a number. It could be true or false. Then in those cases, to check whether the number is actually a number or not, we use this function isIn. So with this, guys, I think we covered a lot today, and this is what we wanted to do for today.